Hi there, my name is Rosalind and I'm an undergraduate biology student. We've known for a long time that cells are the building blocks of everything alive, and that what gives each cell its unique function can be found in its DNA. Now, my classmates and I are currently developing a new technology called artificial cells, which are cells that have been deliberately designed or modified by humans to perform useful tasks. There are two main approaches to building artificial cells. First, there's the bottom-up method. This technique draws from a combination of natural and synthetic biomolecules to recreate the three core components of any basic living organism. A semi-permeable membrane, much like the phospholipid bilayer found in natural cells, is needed to provide support and a means of communicating with the outside world. Next, a system of metabolism will need to be put into place so that the cell can draw energy from some kind of source. And finally, the information storing molecule will need to be engineered so that the cell's unique traits can be stored as genes. This start-from-scratch method is useful because it allows scientists to experiment with radical new ideas. Some examples include replacing the sugar-phosphate backbone of DNA with a polypeptide, and even the addition of a completely new base pair to make an information-storing system with a larger capacity. However, these cells have a limited application outside the lab, since they're just a bit too alien to interact with natural cells in any meaningful way. Another more promising approach is the top-down method. In this technique, we start with an existing cell and alter its genetic information in order to turn it into a completely new kind of cell. There are many different steps to this process. First, the entire genome of that cell must be sequenced so that we know exactly which genes do what. Next, gene knockout tools such as CRISPR are used to cut out all the genes not directly needed for survival. What remains of the cell is said to have a minimal genome, which biologists call a chassis. In the auto industry, a chassis is a car's basic framework, which can become many different types of vehicles if the right parts are added. In the same way, a cellular chassis can become many different types of cells if the right genes are added. MIT, Harvard, and many other upstanding research centers have compiled online databases of thousands of DNA segments, which code for everything from promoters to coding sequences to terminators. By combining these small parts, we can build complex biological systems, which can then be inserted into plasmids to be transferred into our cell. So how can this technology contribute to society? Well, one area that will definitely benefit is healthcare. Designing artificial cells with diagnostic and therapeutic functions is a huge priority right now, and lots of progress has already been made. For example, we have cells in our bodies called helper T cells, which are supposed to sense foreign substances like cancer and alert the immune system. However, these cells are often not sensitive enough and remain dormant until it's too late. Recently, a hypersensitive artificial cell was designed to help activate these dormant T cells in time. As more and more discoveries like this emerge, treatments for diseases like cancer will likely soon shift from invasive procedures like chemotherapy to helping the body heal itself. The pharmaceutical industry will also benefit a lot from artificial cells, particularly after the invention of cells that can produce terpenoids. Terpenoids are a large class of organic molecules, which are found in plants mainly. They have many useful properties such as having pleasant smells and fighting inflammation that make them key ingredients in household products like soap, detergents, and perfumes, but also in medical products like lotions, anti-inflammatories, and anti-malarial drugs. Being able to produce these compounds with artificial cells means we no longer need to harvest them from plants. And more importantly, this decreased cost of production will allow crucial medications like anti-malarial drugs to be distributed to third world countries in need. Artificial cells are also seen as a potential source of clean energy. Right now, much of our world still depends on fossil fuels and natural gas to power our electronics. However, making energy from these sources releases large amounts of greenhouse gases into the atmosphere. Furthermore, these sources are non-renewable, meaning they're doomed to run out. Researchers are getting closer to designing an artificial cell that releases a clean source of fuel, like hydrogen gas or ethanol. We would be able to power our cities for thousands of years to come, while giving the planet a chance to recover. And of course, students like me benefit greatly from this exciting new field. And like many other subjects, new insights in the study of artificial cells are ours to discover through interactive hands-on learning. Over the past few years, programs like the International Genetically Engineered Machine Contest has spurred undergraduate students like me to make dozens of contributions to the areas I just mentioned. While these benefits definitely sound promising, artificial cells still carry many challenges in the road ahead. For instance, although many diseases may be treated or cured by artificial cells in theory, there's simply not enough information yet on how a real human body would react or the adverse effects and complications that may arise. If the capacity of artificial cells to produce fuel and pharmaceutical molecules is exploited to its full potential, it's possible that entire industries such as mining for fossil fuels and traditional chemical manufacturing could quickly become obsolete. Despite their negative impacts on the planet, these potentially affected fields currently employ several million people in North America alone, providing a substantial foundation in the global economy. If growth of artificial cells occurs too quickly, the current climate change crisis may well be replaced by an unemployment crisis. The purpose of engineering artificial cells is primarily to help people. However, in our fast-paced capitalist society, research teams and companies can't help but be motivated to get ahead of their competition by patenting their ideas as often as possible. However, over-patenting a useful information, such as newly discovered DNA sequences and innovations in biological systems, could easily lead to the establishment of monopolies, where information is not shared equally among the scientific community. This situation would prevent collaboration and slow down progress, resulting in the benefit of a select few companies, instead of a society as a whole. On the other hand, if online databases for DNA sequences such as BioBricks become too readily available, it may make it easier for terrorists and even federal governments to obtain the information needed to create and stockpile bioweapons. History teaches us that scientific progress often moves too fast for the ethical maturity of human nature to keep up. Just as nerve gas was invented as an insect repellent, but then was quickly exploited for chemical warfare, artificial cells could just as well be used to create deadly pathogens in the hands of the wrong people. As this technology becomes more widespread, it is also sure to cause controversy in society, both in the general population and the scientific community. Perspectives rooted in cultural or religious beliefs may compel certain groups to see the deliberate design of organisms as recklessly playing God, while others, such as a scientist from MIT, have this to say: the genetic code is 3.6 billion years old. It's time for a rewrite. Canada's scientific community is internationally recognized for its leadership in the study of artificial cells. In the past few decades, Genome Canada and other Canadian research centers have invested more than $2 billion in tools that may be helpful and applied to this field. Both the United States and the United Kingdom and the European Union are also highly supportive of developing this new technology, and have placed substantial funding on creating organizations such as the EU's new Emerging Scientific and Technology Programme and the UK's Network in Synthetic Biology. However, global leaders all agree that current laws and regulations are in urgent need of updating in order to address issues such as over-patenting, bioterrorism, and uncontrolled release into the environment. Some suggestions made by the Panel of Biotechnology and Biological Sciences Research Council include the development of an ethics advisory committee, mandatory surveillance of high-risk research projects, and more clearly defined restrictions regarding who has access to classified information. If effective laws and regulations are well enforced in the coming years, society 30 years in the future could differ from now in several positive ways. With the majority of electronics running on a clean energy source based on artificial cells, human-related climate change may no longer be a threat to the environment. As new generations move into the workforce, employment in areas involving genetic research and biotechnology may slowly take the place of current jobs in mining for fossil fuels and chemical manufacturing. The more efficient and eco-friendly production of pharmaceuticals may drastically decrease the cost of life-saving medicines, allowing a large-scale increase in the global outreach to the developing countries in need. Due to their widespread use in society, artificial cells and information about genetics in general will become a large part of the elementary and secondary school curriculum, allowing the general population to have an understanding of the technology's benefits and potential risks. When considering its possibilities in medicine, industry, energy, and research, I'm inclined to feel optimistic about the future of artificial cells. I see it as a big step in our collective journey to becoming a more sustainable and interconnected world. That being said, it is a technology still in its infancy, and I'm sure that it will take some time to be accepted by society at large. Whatever the future holds, I'm extremely excited to be taking part in this research.